Thank you for joining Moderna's webinar on Scan-to-BIM with InfraWorks and Civil 3D. My name is Salome Fourie, and I'm a Civil Infrastructure Accounts Manager. Presenting today will be Andre Himan. Andre is one of our applications engineers, part of Moderna's infrastructure team. Please direct all your questions to the Q&A box. All the questions will be answered at the end of the presentation. This webinar will be recorded and will be emailed through to you shortly after the webinar. If you have missed any of our previous webinars, you are welcome to come and visit our YouTube channel. For any other queries, you are welcome to email or contact me, and I'll set all my details in the chat box. Andre, over to you.
Thank you, Salome, and good morning, everyone. Welcome to Scan-to-BIM in InfraWorks and Civil 3D. So just a brief overview. Scan-to-BIM is the process of taking LiDAR or photogrammetry data from an original source and making it a meaningful contribution to an information model. So just the basic overview of the workflow. We firstly start by going to site and capturing all of the data by use of a laser scanner. This can be in the form of a drone, or for example, what we generally use at Moderna is our Faro 3D scanners, our point cloud scanners. We then take this information over to Recap to register and perform some cleanup on the point cloud itself. Then from there, we move over to our design tools, which include InfraWorks and Civil 3D. They include some fairly powerful tools which you can use to further your design. So just to continue on with that workflow. So we firstly start by processing the captured data. After we've gone to site, we've performed our scans. We then go back to the office. We take our information and our scans into Recap to process, register, and export that data. So we usually export it in the form of an RCS for use in InfraWorks. In InfraWorks, we can then generate surface topography from these point clouds. We can then use this combination of surface topography and the point cloud to extract certain features. These features can include roadway edges, curb lines, drains, basically anything you can think of that you would be able to trace with a line. From there, we then take this information over to Civil 3D. So after processing everything in InfraWorks, extracting the features as a shapefile, we can then take it over to Civil 3D, consume the data there, create our surfaces to then create our as-built designs from. So, how is point cloud data used? So firstly, if you're interested in only using the point cloud data, you can use it for things such as visualization, performing measurements, or using it as a design background. Using it as a design background means you would import this point cloud into your design software, and you can then use it as a feature as a whole to perform a design from. You can also use it as a basis for feature extraction. The features that you can extract is data such as geometry and surface topography. But you're not limited to those two. You can also use it as a hybrid. So yes, you can extract the data from it, but you can also use it as a design background at the same time, or you can use it to base your visualization on while using it for your surface topography and geometry extractions. So just some typical tasks that you can perform with Scan-to-BIM is firstly to take measurements inside of the point cloud itself or inside of the design software where you import the point cloud into. You can also use it to create points of features, in other words, edges of your roadways, your curb lines, your drain lines, and so forth. You can also use it to create 2D and 3D line work. 2D line work in a sense of site design. So you can create a 2D site plan from a 3D point cloud, but you can also use it to extract 3D line work. And these would be your features, once again, such as your road center lines, paint markings, so that you can actually use the levels of these objects. You can use it to create 3D model geometry. So the 3D line work would then be put into use in the next step, which is Civil 3D, to actually create the model geometry itself. So when seeing those then in section, you can, for example, create a cross-section of a road, or you can model a road by use of corridors. We can use it to create topographic surfaces. So you're not limited necessarily in that sense to roads itself, but you can use it, for example, to create a parking lot topography. You can use it to create stockpiles at mines and so forth. Use as a design background, which we have briefly covered. You can also use it to calculate materials and volumes. So for example, I like using the example of a stockpile at a mine. So by use of actually creating a ground surface and then creating a surface for the stockpile itself, you can calculate those material volumes. You can also use it to monitor earthworks, construction, and commissioning. So if you perform scans at regular intervals along the project life or along the lifespan of a project, you can actually compare certain phases to each other, and you can then use those different phases. For example, a scan while there's an excavation in place versus a scan where the road has already been built or before the excavation has taken place. You can then use those different scans to generate surfaces and to calculate and monitor earthworks. So how is point cloud data created? Well, there are a few different ways. So one of the most common ones would be LiDAR data. That is light detection and ranging. So if you look at that top right-hand image, for example, with an airplane retrofitted with a digital camera and GPS system, they can use those systems to perform high-level scans at certain grid intervals over land or even of the sea bottom. Then you get photogrammetry, and that is the extraction of 3D measurements from images. So using 2D images to create 3D models. Then you also get GIS repositories. Although it's not a form of point cloud creation, but rather a source from which you can extract it. This is, for example, ArcGIS, where you can select a area, and you can then extract point cloud data or LiDAR data from that interface or from that software to use in your design softwares. And I think the best example of that would be, for example, the image on the bottom right-hand side there. That is an aerial survey or an aerial scan of a development with looks like a mountain range there on the right-hand side. So I just want to take you guys quickly through a basic example which I have set up. So I'm now in InfraWorks. This is live. So I have a point cloud. This is on Jan Smits Road, and I have a little side road here which I have decided to go and model out. So when I zoom into this, so note that I went into recap after receiving the point cloud data. I went over to recap. I trimmed the model down just to include the roads and the fencing there, just so that I can get a little bit of a more toned down version of the model itself. So what I did then is, after bringing it in to InfraWorks itself, I went ahead and extracted some linear features. So I have this side road here, and you will see I have a center line, and I also have these green lines here on the side. Now I used the InfraWorks point cloud tools, which I'm indicating over here on my screen. I use these tools to create linear features. These linear features can include different styles. I can go ahead and choose different styles for my lines. I can create, for example, bottom of curb, break lines. I can create different styles of break lines, a center line for my road, edge of pavement, paint striping, passing lanes, top of curve, and then transverse lines as well. So what I've basically gone and done is I have traced out this center line over here. I've extracted that information. Just close this down. I've extracted this information and then placed edge of curves as well. So you can do this manually or you can do this automatically. Doing it automatically will require some additional setup on your side when generating this point cloud or when actually exporting this point cloud. But what you can do then, you'll see I have this center line selected here. Let me just show you guys what these ones look like as well. There I have the other edge of the road selected and this side as well. So I have the edges of my road traced out here as well as the center line. What you can do is you can actually view these in cross-section mode and place down points of interest. So as you can see, I have the bottom of curve, which in this case is actually the same as my edge, as the edge of my road. At some places, I do have a little bit of a channel. I modeled them out as the bottom of a curve and also here as the paint stripe. I could have also done it as the center line, but this does not have any bearing on the design itself. It is just an indicator of what you're using. You can then go ahead and navigate through these different objects and you can adjust vertices where needed. You can set up certain criteria whereby you can move through the lines at an interval and where you can also do auto vertex cleanup. So I can move throughout the vertices and you will then see that you get an indicator showing you where you are along this line. So as I move through these lines, we'll see it shows us a section of a point cloud. And at any one of these points, I can go and adjust these values on these other features if need be. What I did then is I extracted this information. So it's all good and well that we have it in InfraWorks, but how do we use it further? So what we do from this point is we can actually export certain features from the point cloud in InfraWorks. I'm going to launch this command to show you what that looks like. So the kind of information you can actually extract from point clouds in InfraWorks is, for example, ground grid points. I'm going to switch that off. The only thing I want to use is my linear features. So I can extract them features as well, including my linear features, my transverse vertices, and my vertical features. I'm going to disable these two, and then also to show you that you can choose which format you want to export it to. So I find it best that when exporting to Civil 3D, we can actually use a shapefile. This is an Esri shapefile. You can also apply a coordinate system to this. So as you can see here, I have applied the Autodesk LO29 coordinate system to it. I've went and verified the coordinate system. I've created the model in the same coordinate system and then imported the point cloud. Now, before I move over to Civil 3D itself to show you what that looks like, I've already created the shapefile. I've simply exported it. I just want to show you how a point cloud is brought into InfraWorks itself. And that is simply done by the use of our data sources. So when importing a data source, you can simply use this drop-down on the far left-hand corner, and you can import a point cloud. This point cloud can be in format. For example, it could be RCS or RCP, a .las or a .laz file. So when working in Recap, I exported the point cloud in an RCS format, and I simply brought it over to my InfraWorks. I configured this point cloud to be on the Autodesk LO29 coordinate system. These coordinate systems can be found when going through the categories. I can type R to go to Republic of South Africa, and I can then find all of these coordinate systems readily available for use. Okay, so I've already exported this shapefile. And what I'm going to do now is I'm going to go over to Civil 3D. Here I have already created a geolocated drawing using a modified coordinate system, which then shows our north arrow in the correct direction. So all of you who are familiar with Civil 3D would know that usually if you use the standard South African Autodesk coordinate systems, your entire view cube would be upside down. So I have just adjusted this so that the north is pointing in the correct direction, and I've also brought in an aerial image on this location. So the road we are going to be importing is this Rothesay Avenue. I'm going to launch a command, map import. So if you want to import a shapefile, you would need to use this command. That is map import. Here I have my shapefile. I've already navigated to the correct location. I will select my shapefile. We just need to make sure that we have the correct file extension selected. And I can then click OK. It will prompt me with the following dialog box. So as you can see, the current drawing coordinate system that I've specified is LO29, but modified for South Africa. The original coordinate system from which our lines are coming is the LO29 Autodesk coordinate system, just the standard one that InfraWorks uses. I don't really have to change anything on this page here, so I can simply click OK. That will then import my 3D polylines. It will import those feature lines that I created in InfraWorks as 3D polylines. Do note that the point cloud is a little bit rough. As you can see, we've got a fairly deteriorated edge here along the side. And that is where that information comes from. So what I can do then is I can simply go and create a surface. So I've already got an empty surface created over here, just called it road survey. I can go and add this information as break lines to my surface. Let's call this features from InfraWorks. Click OK, select the objects, and hit enter. Now it will require a little bit of cleanup, but that's at least not as hard to do. I'm going to quickly do that. Let me put these on triangles. And I can simply go and perform a little bit of cleanup here. Just deleting some of these unnecessary triangles. After doing that, I can simply take the surface back to its original style. I've just got a minor contour of 0.5 meter and a major contour of 1 meter shown. And there I have my as-built survey of my road, contours and all. We can then go ahead and create an alignment through the center line of this road. We can go and perform cross sections to showcase some of this. So if I can quickly show you what a section like that would look like. I'm just going to go and draw a quick profile here. And there I have a design profile of how this road center line is moving from the start towards that intersection tying point. I can then use this as a design profile to go and do my road design from. From there, you would simply go and set up your assembly and run your corridor along an alignment. And that is how you would use scan data in a BIM environment by use of InfraWorks and Civil 3D. So that concludes the presentation section for this webinar. Are there any questions? So I see Lee has a question there. The question is, how long does it take to process a point cloud for use in InfraWorks? Well, that's a very good question. It actually varies. It all depends on how big your point cloud is. For example, my point cloud that I used in this for this webinar, it took me around 45 minutes to export it, but that's just the processing time. The actual work that has to go into a point cloud beforehand can also vary quite greatly based on the amount of scans that you have, as well as the computer system that you are using. So for me to clean up this entire point cloud, cut out all of the buildings and clean up the roads, remove all the noise, it took around, I would say, around 2 hours to clean up that scan. And this is relatively small still. Okay, there's another question here. Is this workflow meant specifically for roads? So no, actually it is not specifically meant for roads. You can use it in a variety of different ways. So if I quickly go back to my InfraWorks just to show you guys, the type of features that you can extract are not limited to linear features. As you can see, linear features, it says extracts linear features from point clouds for road designs, such as lane lines and curb lines. But we also have vertical feature extraction. You can use this to extract information such as trees, street lights, and signs as well. So you can use it in a variety of different ways. So there's a question here from Kelly. That surface can then be published to ACC and consumed by Revit. That is 100% true. So I can actually go over to my Civil 3D after creating this surface. If I'm connected to a BIM 360 project, I can go to my output tab and I can publish this surface to that specific project. So that is 100% correct. There's another question here. How accurate is the data which is extracted from the point cloud? Okay, so once again, another very good question. So this all depends on the method of scanning. And then as well, there are some additional factors as well. So in this case, I believe on the point cloud, we had an average accuracy of about 5 millimeters. So the scan itself is accurate up to 5 millimeters itself. From there, it all depends on how you create your feature profiles. Are you using the automatic method or are you using the manual method? In my case, I use the manual method. So it's good enough to work with on an as-built level. If you create many vertices along this road, as you can see, I've got many vertices at the beginning here. I believe this is every 1 meter. But you can go down as far as a millimeter to go and place a vertex at every millimeter and a point on that surface at every millimeter. So it all depends on your approach. Are there any other questions? Feel free to ask. Okay, there's a question here from Heinrich. Where would I find the latest geolocation data? I notice sometimes the difference compared to Google. Okay, so when it comes to the geolocation data, let me just quickly go back to my Civil 3D here. Note that the imagery that is being used is from Bing Maps. So the information that we have here is only while the automatic aerial imagery in Civil 3D is only as current as big maps themselves. But you can extract probably, it depends on when the aerial imagery was taken, when the last flyover was. You can actually extract aerial images from ArcGIS itself as well, and export those as XYZ files or as GeoTIFF geolocated images, which you can then use in Civil 3D. Great. Okay, so if there are any more questions, okay. Question from Nigel here. Is InfraWorks or any other Autodesk program able to produce a mesh from the point cloud? I believe that your meshes, you would do those from Recap itself. So you would do that from the RCP file itself, I believe. I've seen some of our visualization guys actually do meshes of machinery and so forth for use in other programs. So yes, it is definitely possible to use Autodesk Recap Pro to create meshes from your point clouds. Another question from Heinrich here. Is it only LiDAR scans that can penetrate water bodies? So that is actually an extremely good question. LiDAR itself, I believe, it's the only one that I'm familiar with that can penetrate the water bodies. But you can also probably, I've seen them use sonar scans from boats, although I'm not sure what accuracy would be working to there. But sonar is definitely also another way. Probably LiDAR would probably be one of the more trustworthy methods. Okay, another question here from Nigel. Can the mesh be imported to further create renders for visualization? It most definitely can. So what you can also do is, after creating these meshes, you can take those meshes over to software like 3ds Max, basically any visualization software, and you can then perform some actions on it, clean it up, make it look nice, and you can actually import those objects to InfraWorks itself to further your visualization process here. So if I can quickly just check what kind of file that would be, I believe it would either be a collada. I know for a fact you can bring in 3ds Max file formats. I just don't see it right here now. But yes, it is most definitely possible. Oh, with respect to Revit. Yes, you can import those meshes into Revit itself as well, I believe. Okay, thank you so much for the questions, guys. Not a problem, Nigel. Will the recording be shared? Yes, it definitely will. It will also be uploaded to our Modern Design Center's YouTube channel, so that you can go and review it if you want to watch it again. But I believe all attendees will also receive the direct link to that. Okay, thank you, everyone. All right, so thanks so much for the questions, guys. I think that's it for the webinar. Thank you so much for joining our webinar on Scan-to-BIM with InfraWorks and Civil 3D. I hope everyone has a wonderful day.